Hello students, this is Dr. Satya Tripathi. In this video, I am going to demonstrate how the crystal structure of barium titanate basically varies as a function of temperature and how you will notice what are the most important features while you report in the journal for different pseudocubic reflections. Okay, so basically if you see the barium titanate is a it basically contains four crystal symmetry. All these symmetries they vary with temperature. As you can see, there is a transition from R3M to AMM2 at minus 100 degrees Celsius, then AMM2 to P4MM at 100 degrees, sorry, 0 degrees Celsius, then P4MM to PM3M around 120 degrees Celsius. All these transitions are temperature dependent, and here R3M means rhombohedral, AMM2 means orthorhombic, P4MM means tetragonal, and PM3 bar means cubic. You can see I have represented this XRD data in various pseudocubic indexing. The most important thing in pseudocubic is that what you will see in 100, the same thing will appear in 200. What you will see in 110, it will appear in 220 the same. But the XRD peaks will be broader. So either you represent 100, 110, 111, the same thing will appear in 200, 220 and 220. That is the most important thing for us. Second thing is that for cubic structure, all those reflections will be singlet. Okay, that is the characteristic. Then if you see, if you analyze, suppose 100 or 200, you can see for 200 PM3 is a singlet. Okay, and but if you go down P4MM, when there is a crystal structure change from 100 below means temperature is coming below 120, this singlet will split into a doublet where inner line will be weaker compared to the outer line, and this thing will be reversed. The peak intensity will be reversed if it tends to below 0 degrees Celsius, where we see P4MM is basically going to AMM2. And again, when temperature is below 0 degree, this AMM2 will come, means doublet will again go back to singlet. What are the most important thing is that in P4MM, this 1 reflection is a singlet, to 200 is a doublet. This is a characteristic, okay? But this thing will reverse when you go to R3M. This is 39 degree peak will be a doublet, and 200 peak, 200 reflection will be singlet. Another interesting feature is that 100 pseudo reflection for orthorhombic MM2. You can see 31 peak is a triplet, okay? And the same thing will happen around 200 PC. So if you see this data, this acts as a standard reference template to understand the crystal structure of barium titanate. People most of the time they do not represent this data to justify that crystal symmetry, which what is doublet, what is triplet, what is means singlet. They never specify this, just do the refinement and say that this is a space group. But the most underlying mechanisms are lying here. This will act as a standard template to understand the crystal structure data for this set of this barium titanate. So I would be happy, I conclude, and I will be happy if I receive any quality questions on this my test box, and I would be happy to answer that. Those who are working with barium titanate, they can take it as a reference to understand their data. Okay, so thank you, bye bye, and take care.